This video will cover Chapter 25, Paired Samples and Blocks, the confidence interval. We're going to return to the problem that we did when we did our hypothesis test about men's resting pulse rates. So I'm going to give you a chance to get all of your data back into your calculator. You see it all on the table right here. I have mine in Stat, Edit, and I have in my L1 my before, L2 my afters, and L3 my differences. If you wanted to just go ahead and make a column for the differences, that's fine. Because remember, we only, in these problems, care about the differences between the two. So we really are only interested in this one. Alright, so you may want to take a moment to pause the video to get the data back into your calculator. Alright, now that the data is back in your calculator, let's look at the conditions that we had previously. They are exactly the same as they were for the hypothesis test. Our data for pulse rates is paired by subject. So we have Alan being a subject and we have his before and after data. So they are paired to Alan. And that's true for every subject. We're going to assume that we have a representative sample of men. I'm not sure. They volunteered to be a part of this study, so I'm not sure if this is a very good assumption. We're going to assume that 10 is less than 10% of all men. I think that's a fair assumption. And then when we made our histogram for our data, only for the differences, it wasn't really normal. So we're going to proceed with caution. All right. So in order to make a confidence interval, just like we usually do, we're going to take some statistic, and we are going to add and subtract a critical value, multiplied by some standard error. And altogether, that is called your margin of error. Okay, in this case, our statistic is the mean difference that we saw. Our critical value is going to be a t-value with some degrees of freedom associated with it. And our standard error is going to be calculated by taking the standard deviation of our differences and dividing by the square root of n. Alright, so let's write down what all of our inputs are. So remember, in order to get those, we're going to go to Stat, Calc, 1var Stats, and I'm going to put mine in L3. Okay, so our y bar d was 2.8, and our standard deviation for the differences was 2.5. Our degrees of freedom is 9, because our n is 10, so we need to find our t star, our critical value. In order to find your critical value, you could probably use your calculator and do inverse t. Because I don't have that on my calculator here, I'm going to go to my table. And we need to establish what level of confidence we want. So let's do a 99% confidence interval. Okay, so again, we want a 99% confidence interval, so let's remind ourselves of where we are here. We have 99% confidence. That means we're looking at 1% on either side. So split up on either side, 1% is 0.5. And so we're looking for 0.005 as the area underneath the curve. So when I go to my table, I'm going to look at 0.005, and I'm going to go down to 9. So when I read that over, I see that I'm looking at, hopefully, let's see, a critical value of around 3.25. Okay, so you should find something similar in your calculator, and make sure that we put it on our calculators. Now I forget what it was already. 3.25. Okay, so we need to write that down. And then once we have all of our inputs there, we can just use your calculator to calculate this for us. Alright, so we're going to go to Tests, and again, this is just like a one sample t-test, or t-interval, sorry. So we're going to go to t-interval. We're reading data in. Data is in L3, and our confidence level in this case is 0.99. Higher confidence, wider interval. Calculate. Okay, so our interval is 0.2 to 5.4. Okay, so we should recall, in order to put our interval into context, we should recall exactly what it is that we were finding. This is the interval for the differences in resting pulse rates. So our conclusion is we can be 99% confident that the resting pulse rate prior to using the exercise machine was on average 0.2 to 5.4 beats per minute higher than after use of the machine. So we just want to make sure that we are clear about which one was bigger than the other when we're doing one of these difference problems. But otherwise, that is it.